welcome everybody. Get started here. I did have to update the slides slightly. I think PDP was mentioning that earlier, the light version, somewhat similar. I had to give a webcast on this morning and it took me an hour. I knew I had 45 minutes, so I cut out a little extra fluff. So we'll get running here. This is the WASC-Distributed Open Proxy Honeypot project. It's an update on Phase 2, and Phase 2 is what we just released in October. The goals that I really have for this by the end of this 45 minutes is threefold. First one, if you have no idea what this project is, or you've heard a little bit about it, what are we doing? Number two is to give you some attack examples, individual stuff that we've seen. We don't dive too deep into overall metrics, trends, stats, and all that. That's where we want to go here in the future. And the last portion is a kind of call for participation. Every time we get the word out there with like quarterly threat reports and more people hear about it and are interested, then I don't have to solicit, which is nice. But we definitely get analysis. So at the end of this, if you think this is kind of cool, let me know, and we definitely need help. Quick slide, just a little bit about me, background, what I've been doing, where my area of expertise is. So mainly my background has been web server administration, so defense of websites. My shameless plug for my book. I do work for breach security, web app firewalls, so this does fit in nicely actually with mod security, which is what we're using for this project. I also function as the mod security community manager, so if anybody here is actually on the mod security mail list, I'm sure we've probably talked to each other before. Also, if you have any questions about mod security, go to the modsecurity.org website and the mail list and get you more info. So this is the project overview. If you go to webInspect.org, click on projects, you'll get to this page. So real quick bullet points. What are we doing here? What is this project? Starting off with the problem statement, Jeremiah laid a little bit of this out in his talk this morning. What we're missing is some real data on what are the bad guys doing. Because there's different points of view if you're a scanning vendor, on that, but is that necessarily what the bad guys are looking at and or exploiting? So we wanted to get somehow real attack data. So this is one concept to do that, one data feed, but we might have different ones in the future. So the goal is we want to identify these attacks. We want to block them. If you know it's an attack, why don't you block it so you don't actually pass it on to the destination website. And the final thing is we want to report on it, which is obviously what we're doing here, to get the word out about what we're seeing. The method that we're using, in this case, the open proxy, kind of unique situation. Why would you choose to do it that way? We'll talk about that on the next slide. And the last one is, what are the tools that you're using? So our tools as part of the project, they are VMware images running Apache that's configured as an open proxy, no access control. But we have mod security installed with the for the honeypot deployment itself. Because as you might expect, and I might say this on a number of different slides, if you run these types of applications in your production environment where you have more control and you know where they're going in the back end, you have a lot better idea how to configure everything. And what we're finding, it's great research, is there's certain rule sets that work great in production, not great here, and vice versa. Website URL down at the bottom. So specifically, why an open proxy versus just putting a web server out there? Jeremiah hit on it again this morning. We tried that. All you're going to really hit or get hit by are worms, things that are just kind of randomly scanning IPs and they happen to hit your system. So the threat that we're really focusing on, ideally, are actual people at the keyboards, where they're trying these attacks out. So that's the end goal that we really want to get to. It's hard to do that sometimes when deciphering, okay, is this a bot program versus somebody at the keyboards? But that would be great if we could identify that. Why else would you do an open proxy? The bad guys use them. From my defensive perspective, right, guarding websites, I was always so frustrated when you'd see attacks. Well, what can you do? Block the IP. Well, what are the odds that that's really him sitting at his keyboard or whoever?
They'll abuse them and wait.
Yeah. So the idea that the bad guys use open proxies, they chain multiple ones together all over the world. I knew that was a problem, so I said, okay, let's shift the focus. Let's have those be our honeypots. So they're not actually targeting the honeypot itself. They just want to pipe their data through it to some other site, but we get access to what we wanted, which was the data. So it ends up working out pretty good. Use their own tool against them. This was somewhat interesting in testing in the early phases. We had to ask some of those questions in deployment, specifically data control. when you think about WAF technology, and I'm sure the other vendors, and when you talk to them, automated learning, all the cool stuff that it can do in production, and auto learn that over time. You can't. So we always had that issue of we're going to identify attacks that are overt. Things that we have rules for, all the known stuff will do that. So that means if there's an O-day that comes out or something new, some evasion technique, could it potentially bypass your system? Yes. So when we were looking here, though, we understood as a proxy, because we're somewhat nervous about that initially, we said, okay, let's put a web server out there, not be a real as an open proxy. We did status code 200, you might trickle. And it worked a little bit if all the things are automated with scripts. But if it's a real person probing you initially, they say, okay, this thing doesn't work, I'm going somewhere else. And that's the person we wanted in the first place. So you do need to give some access. You need to let them use you as an open proxy. This is one example looking in the centralized console where all the sensors are search here just to demonstrate exactly what I was talking about. You normally get these initial probes, which if you have super eagle-eye vision, you can maybe see that in the back, but initially you're going to get a request where they're saying, okay, go through the honeypot and go to this proxy check website to make sure that you actually proxy them to that. Normally those sites will echo back some information. So number one, they find out, yes, you're an open proxy, and number two, how much info are you giving away about me? Exported for, whatever. So they're going to try this. If this works, then they start sending stuff. If this doesn't work, they go somewhere else. So what are we reporting? Real data captured, in the wild. Data is taken directly from our honeypot systems. And as I mentioned, we're really focusing on individual attacks just to show you examples, because I'm not comfortable at this point making any sort of claims about this being like representative samples of exactly what's happening. We have limited view at this point, but it's somewhat interesting. So why are we reporting? Just public awareness. We do want to help some of these other WASP projects that talk about, like such as the threat classification or statistics, to either back that up and say, yeah, what you guys were saying is there, that's what they're targeting, or to debunk it and say, well, we're not seeing anybody even go for that. So hopefully it can back up some of that, the assumptions that we're proposing there. And yeah, some of the debates here, we often talk about that too. I'm sure if you're on the web security mailing list, there are so many cool attacks that are possible. I refer back to a lot of what, I always butcher his name, Amit Klein, like request smuggling, response splitting, all this cool stuff. Yes, you can do it, but how many bad guys are doing that? And ultimately, is there money involved? Because that's really what they're going to be targeting. So it's that idea of these are all the things that are possible, threat classification, and then maybe trying to categorize criticality that, hey, based on you might want to look at this because this is what the bad guys are doing. So that's what we want to get to down the road, some good statistics for that. So phase 1 of the project we released in January of 2007, and I had to solicit people, say, please help me, and I'd explain everything. I did get some people to participate, but as an open source project, some of the sensors that were online for a couple weeks, a couple days, on and off. But over that 4-month period, January to April, out of that, we had only about 250,000 that were tagged as malicious. So you still had that remainder of what was it. So think about the kind of ratio there. Well now, after we released the initial threat report back in May, now there was a lot more interest. I didn't have to solicit people. Woohoo! They said, hey, that's kind of interesting, I want to participate. So we had a lot more people on deck. We finally made some updates, a very critical update, not only just updating the mod security software and better rules, because we learned things from phase 1, is we had an auto update feature where previously in phase 1 I was pulling my hair out because this is a great testing ground for mod security rules. Anything that you can think about, hey, let's try this, see if we can identify this, track this, do whatever, we put it out here and just see if it works, because if it blows up, who cares? The problem was, all I like to do is send out an email to the group mail list and say, hey, everybody put this in there. Would they do it? Would they ever do it? Who knows? Would they do it right? And it was very kludgy, no real time, no consistency. So now we have an auto update feature. So the VMware host every hour will check in with the central console, download any rule updates, new software, what have you. So it's much better. It's more efficient. So lessons learned from phase 1. Phase 2, you can see we have some more systems online. So it is distributed globally, many different countries involved. I've been talking to a few people in between some of the quite interesting, because as you might imagine, so maybe questions in your head here, are there legal issues potentially involved? Sure. We have on an FAQ on the website, if you want to read about that, things you need to consider. We are bannering our systems to allow us to look at things. However, depending on the country you're in, there's different laws. Some of this stuff is US-centric. This guy contacted me and said, hey, we're down here in Buenos Aires, we got no laws related to this. He said, we can pass a tax. As a matter of fact, we want to do that. Do you have a, so I kind of back up. I said, you running the sensor, when you register if you want to participate, you take some of the onus on you, ownership of how it's configured, because some people are a little gun shy, they want to participate. All you have to do is change one setting. If you want to be just a web server, but still send us your logs, that's fine with us. We'll still get some data. But when you switch it to be an open proxy, yes, there is a little bit of risk that you're inheriting there. So the third option, though, is if you really want to participate, but you don't. Because he said, oh, no, that doesn't matter to us. We're not going to get in trouble. So he registered. Actually, his sensor's not online yet. But these are some people that have helped out, either deploying sensors, helping with analysis, or what have you. So a little shout out to those folks. Project architecture just works here. So you got your bad guy down there in the target where he wants to send his data. He tries to loop it through the process. Sends back a status code of 200, so they might think it worked. Then it transports the audit log across the internet to our console. And then you have the nice WASC white cat guy coming up in a second. Then you log into the web interface and you analyze everything. So that's kind of the architecture that we have here. So of course, this guy, I think we have about 14 or 15 out right now. This is the dashboard, so when you initially log in, when you look, there's a couple guys that are active. If it hasn't been active in a while, we flush some things. Some statistical information, high-level stuff over on this side. What's interesting is the gray information is total transactions. The, what is kind of orange-brown, whatever color that is, those are things that are tagged as attacks. So you can see the difference there of kind of uncategorized data. So that's really what we also want to focus in on. Are we missing things? What is that? What's going on? Live active alerts as they're coming in real time. You can get a different viewpoint here. As you might guess, sometimes there's so much data coming in, it's really not feasible to just sit in here all day and click on individual alerts. So you can group things a little bit differently. Maybe if you're interested in a specific IP address, so it groups it here, and then you can look at the total number of events that they've triggered. Or you might say, I'm only interested in looking at severity 1 issues. So there's different ways. Being from breach and commercial stuff, working in production networks, I've always been in the alert interface. Real time, incident response, get this done. This has forced me to abandon that and go for batch analysis. There's no way you're going to keep up with those in real time. So here you have the search interface that you can go in and put in any part of a transaction you're interested in. A date frame, an IP address, a URL, a response code, an alert message, and you just do batch analysis, and then you get the results back, and it gives you a different viewpoint overall that you might miss if you're just looking at individual alerts. So we are using some mod security rules out of the box, but here's a couple customizations we did make specific for the honeypot deployment. One of these is mod security can do a real-time blacklist lookup. That feature's there for anybody who wants to use it. In production, a lot of people don't, because yeah, you're making some DNS queries, it's extra overhead. Honeypot stuff, we do not care about performance. That's one cool thing. No performance issues, which you cannot chain down there. Tracking brute force attacks, specifically basic authentication. Mod security can do persistent collections. So you're no longer just looking at one transaction. You can keep a persistent collection and start tracking from request to request. And so we're setting some thresholds. If you fail authentication more than I think like 5 times in a certain time period, we'll blacklist you for like 20 minutes. So that's helpful also when you think about that data control I said at the beginning. So yes, somebody might go through our system to, in this case it's almost always porn sites, trying to break in, but if we see it at a certain point, then we're going to stop them, and they can't keep going. So there is some data control we're trying to implement there. Also, you can, instead of, this is tracking based on IP, You could go a level deeper and start tracking somebody based on the session ID that they give you from the app. So we've implemented that. That really helps when you're doing a transactional search. So if you find anything that may be flagged a mod alert and there's a session ID. And then last one, somewhat interesting, credit card info. I think Jeremiah or somebody asked that question earlier today. We do have some rules that identify credit card information going inbound or outbound. I'm just interested in overall metrics because I'm thinking, okay, maybe bad guys, we hear about that, right? They're dumping stuff from SQL databases, stealing credit cards, so we could potentially identify that. However, we don't want to store those credit cards, the info, just like the whole PCI thing. I'm sure use asterisks and star out the credit cards. We don't want those. So. Traffic categorization. You have three main categories we're dealing with. I still laugh at the first category, normal web surfing. We have people that are just using our proxy to surf the internet. So nothing overtly malicious. You have other ones that might trigger mod alerts where something's kind of abnormal, missing request headers, who knows what. But looking at it, you can't identify anything where it's like, okay, they're trying to do an evasion to do this attack. It's just something's anomalous about it. And then you have avert stuff that are malicious attacks, we block it. So really though, what we're getting to is all that data that we didn't classify, what is it, what are we doing with it? So, as I said, moving forward, that's really where we need some help. A couple slides on high level, pretty crude statistics. I want to give you a little bit of an idea of the data sets we were working with. So the total number of transactions we logged just for October was almost 9 million. Total number of alerts generated just over 2 million. Total unique IPs that connected to the honeypot sensors was just over 46,000. However, knowing we're an open proxy, who says the IP that connected to us might not be an open proxy? So we can go one level deeper and look into exported for headers and grab the IP. How many of those were there? Well, there was another 61,000. But still, that's maybe one hop back. How many proxies are they chaining? We can only go so far. And then total number of unique target sites, destinations they wanted us to go to, just over 171,000. General trends that we noticed, not just from the mod rules, but trying some batch analysis techniques. For those transactions that didn't trigger mod rules, what are they? This is some of what we're trying to get to. It looks to be a lot of banner ad and click fraud, where if you just looked at one transaction and somebody made a request going through to some banner page, do you have a rule that's going to block that? Well, no, not out of the box, but it's not until you look holistically at that IP and you see they're hitting that thing 10,000 times in a half hour, to drive up their revenue, then that's a problem. Spammers are probably the second highest category. Two different things we're noticing. The HTTP connect method is a big pain from a logging standpoint if you've ever messed with those. All it's trying to do is say, hey, open proxy, make this connection to port 25 on this email server. Once you make that, I'm going to send all this email through it. From a logging perspective, it's tough because all you see is the initial connect and then you don't see anything. It sets up that data pipe and who knows what goes through there. So what we're actually doing is we're not letting them set up that pipe. We're logging the transaction, very low severity, and auto-archiving it to the database. We don't want to see that in the alert interface. There's not much intelligence there until maybe you do some statistics later on. The other thing we've seen a shift though with spammers are, they've really made a move to following all the web technology trends, all the user forums and blogs and community sites. All the stuff you normally get in your email, which you still get, I'm sure, that exact same HTML page, they're now doing a lot of Google hacking through our proxies to identify sites that have blogs and PHP stuff, and then they're trying to post their spam to those. So majority of attacks are automated. We're still trying to identify the individual person at a keyboard trying to hack. Like if some of you are here at before we started, like remoter, some guy's sitting there trying to hack. That's really what you want to get. But still, identifying automation, statistical analysis-wise, it's the vast majority of what we're seeing. Information leakage is a huge, huge problem. We have some slides at the very end, that's the last category we talked about, where most people think, oh, well, information leakage, if I stop all the inbound attacks, then that'll never happen. That's a certain mindset, but until you have data to say otherwise, what we're seeing here, lots of the outbound stuff that we're flagging, it was just somebody making a request to the website, but for whatever reason on the back end, the application choked and died, and it gave all these detailed error messages. So look at each vulnerability individually, and how would you prevent spoken about all the time. Definite evidence of that. Pick a vulnerability and then scan everybody and see who has it. Rather than somebody specifically targeting one site and how do I break in. There's one example against that though where somebody's actually targeting a site that we'll get into. And also definite evidence of proxy chaining. Just some trends going back to automation. Mod security has a bunch of different rule sets where it'll look for different request headers that should be there for using a browser, but they're missing. Things of that nature, RFC-wise, that should be there. So I kind of group those into one category. That's this guy. So clients that don't include legitimate headers that browsers would send, that's the vast majority of attack traffic that we saw. Some other categories, spammers. This could be related to worm activity. That's originally why we put the worm in. Right? When worms are propagating, they normally put in an IP address rather than a host name.
It's also a good way to find internal hosts that are behind reverse proxy.
Sure. So yeah, I mean, anybody coming to a legitimate production website should probably have some sort of virtual or host name. So that's at least anomalous, you might want to look at it. UTF-8 encoding, that's not necessarily an attack, but sometimes you want to flag it because there have been things in the recent past as well for like, what was it, like Unicode, full width and half width encoding, all sorts of encoding things you at least need to identify because it could be used as evasion. But then also the real-time blacklist checks that we were doing. For a lot of people that have been reported by other sites as being malicious, so we just went ahead and blocked it. Some different attack categories, once again, from mod security rules. So it's interesting just to see certain things that were flagged. Take with a grain of salt these numbers because false positive rate in a honeypot environment goes up. Some interesting things here, as I mentioned before, some of these attacks. I saw, response splitting attack, cool. I hear about it, I know how it works, what is it? And then I look at every single one in hopes that it gets posted, and they want it to be formatted a certain way. So they start putting all those control line feeds and characters in there so it's formatted if it shows up in the blog.
The signature is actually double CRLF, right? Not just a carriage return?
Our rule will look for either the 0A or 0D. It looks for both of those. So, you know, we have some high-level rules looking for certain things, but then you have to qualify them, is this a false positive or not? So some of these are false positives. Other ones are very legitimate. So we can go into some of these when we get the example attacks. So now, doing some good synergy with the WASC projects, I like to map these back to the threat classification. Now, this is kind of a hybrid between version 1 and then version 2 that we're working on because some of these were moved into a different section. So we're going to go through quickly here and show examples in all these categories. So let's roll through. So brute force attacks, head method. All right, so you got the bad guy. He's sending his head request to, in this case, nice porn site, basic authentication header. So he keeps making the same request, and all he's doing is rotating the basic credentials, and he's waiting for the status code to come back to change from a 401 to a 200. If it's a 200, cool, marks it down, these are valid credentials, keep scanning. So we start scrolling through here. Now we just changed it again. Because we have the basic authentication rules, this is how it would kind of show up in the management interface. We blocked it, we blocked it, we blocked it. Now he went over the threshold, and now we have a different message. Saying, okay, for the next half hour, we're going to block this guy because he's done too many authentication failures. This is one that was pretty interesting. We saw evidence of this in phase 1, so I kind of knew to go back in phase 2 to see if they were still doing it. First aspect here, a reverse brute force scan. Our Barnett's account and trying to target me and pick a different password. They're targeting a common password and then just cycling through the user account. So if you pick password 123, test, whatever. Why this is somewhat stealthy, of course, is because most people doing IDS or at the app level are going to focus on somebody targeting an account. If you fail too many times, maybe you're suspended for a little bit or it gets flagged. Not as many places flag this because it's only going to be associated with an account once and then you're on to somebody else. Now the other reason why this is stealthy, it's also a distributed reverse brute force scan. So now you jump over here to look, okay, This is who they're targeting, but where are they sending it to? All these different authentication servers around the globe, essentially. So this is just a small data sample, and of course we're sanitizing certain information to not make it very obvious of who the target is. We're more interested in what they're doing. So the other thing that in this aspect, they're sending their credentials, and then how do they know if this worked or not? Well, in this case, looking for a 200. If it did not have the right credentials, it's going to be a 200, and they can just grep for text such as invalid ID or password. If they get the right credentials, it's a 302, and there's different text that they can identify. So that's very easy to script. However, you are still parsing HTML, and maybe it's slightly more complicated. So what's funny is now, so they were going to a normal login page. Now they found a different application where it looks like it's maybe geared more towards a web service, where clients maybe shouldn't directly be accessing this, because the response back out is a one-liner text field. It's not an HTML page that a normal user would look at. So they're still doing the same reverse brute force scan, still distributing it, it's just a different app. So what was interesting is, okay, why are they doing this? If they can guess the right credentials, great, now I can take over your account and send email from your account. That'd be nice. So here's what they were seeing in the text that came back. As I said, it was a very small one-liner. If it was the wrong username, it would be an error code of 102, say invalid login. If they hit the right login but the wrong password, it was a 101, invalid password. If they hit the right credentials, it's okay, and then it'll tell you what the username was. So no. Ooh, did they hit any valid accounts? And the answer was yes, they hit 2 of them. So they had the right username and password. Of course, that's obscured as well, but you get the idea. Some other categories. Insufficient authentication. Lots of what we're doing here is mapping it back to the threat classification and then taking out some examples just to show you. It might be hard 100% to say successful attack, but it might be indications that they might have this vulnerability. Anytime you right? Just change it to a 1, what happens? Credential or session prediction. When your apps are giving out set cookie and it's got information in it, how much entropy is there? How random is it? Are you just giving somebody a hash, or are you giving them a whole bunch of information that maybe should be on the server side? So once again, went in, just searched anything that was set cookie, and I just pulled out a few examples that might be of interest. Right, let's put 1414. Who am I? What happens? Did I take over somebody's account? Current session cookie we'll look at on the next screen. Cold fusion, you're just looking at IDs that are small, so it's very easy maybe to manipulate those. Anytime you know that in the cookies they're tracking referrer fields, that's information to an attacker. They might know if they're targeting something that's deeper in your website. Okay, I gotta spoof that. They're gonna evaluate it at some point. The bottom one down here too, indication-wise, maybe some intelligence. You can tell here they're including an IP address, so the attacker would then know, okay, they're correlating that somewhere, so I need to factor that in and maybe break into that system or come from the same subnet, something like that. Another thing that you might run into problems on, looks to me like there's some sort of session ID that maybe the app said, okay, where this user is, they're authenticated. And then down here you have some other number. Is it an account ID? So the big question is, are they correlating that with this? Right? Doing pen tests, past experience, they don't always do that. You just go in here and change this number. Say, oh, now you're a new person. Are you authenticated? Yeah, that's a valid session. So it's just indications out there in the wild web apps that might be in trouble. Back to that current session ID, how much entropy is there? I specifically did a search just to grab some samples on that. And you can see 12 characters, but how many are random? Only the last 3. If you just looked at one, you might think, oh, it's 12 characters. That's not too bad, kind of long. But then they can start twiddling with those, and who knows who you'll become. Insufficient encryption. In this case, just base 64 encoding. Of course, trivial to decode. So you get this cookie, and you're the bad guy. You just decode it. You look at all this data. That ideally, that should be all on the server side, right? Just give the client a hash, and then when they send it back, then you can access that locally. Looking at the end here, they have a name, and it's just what if you then take it and change this to 5 characters, admin, base 64, re-encode it, and send it in? What's going to happen? Who knows? So these are just indications that web apps, there's some things maybe you want to change.
Well, the fact that you're seeing all this data is insufficient encryption, right? I mean, because it's all passing through your clear proxy.
Well, in this case, they were just talking that category. But you're right. I mean, are they going over SSL versus clear text? But, the next main category being web defacements. We didn't see near as many as I thought maybe we would see, but there's still some evidence. This category that I placed this under with more insufficient authorization could potentially be now in the new threat classification, maybe misconfiguration. Very easy, right? Pick a vulnerability, scan anybody that will accept configured or didn't have proper authorization, access control. So insufficient session expiration, are the problems there? Tons of cookies being sent out with absolutely zero expire parameters on them at all, so like never expire. Or something like this, why even put on a session expiration if it's going to be in the year 2107? I don't know. Now another question happens in a lot of environments. If somebody actually clicks on log out from your web app, what happens? On the back end, what do they do with the cookie? I mean, are they expiring the session, getting rid of it, it's no good anymore? Or are they just doing something like this? Send it down to the client, whatever that value was. Oh, it expired, you know, back in whatever, 1970. And hope that that's sufficient.
That's Yahoo, isn't it?
Where?
That's Yahoo, isn't it?
Some other cookie just issues, things to look at. I was kind of surprised to not see a lot of usage of HTTP only or secure. I thought I would maybe see more. So pretty trivial to add, but you know that might help to some extent for some process scripting types of attacks. Or at least trying to protect it so it doesn't go over clear text. So you know, maybe the site doesn't even offer an SSL site, so they never use that. So that's when you take some of this data sampling and what we're seeing with a grain of salt, but I thought I would see maybe more of that. Session fixation. Actually, I think Jeremiah's in the back there. We had a little conversation on this as well. It's all about visibility. When you think about session fixation attacks, normally what people think about how it would kind of work, an open proxy honeypot isn't in the right location to see the entire workflow to identify this type of stuff. If it's in a production environment, you have a better chance. Web application, and you give me a session ID and I haven't logged in yet, and then I send a phishing email to a legitimate user and I put that session ID in the link that I send you, and you click on it and you go and log in. Session ID is now active, I know what it is, I can log in. That whole kind of typical workflow, the only thing that we would see potentially is if the bad guy, after he sends you the email and he's waiting, when he goes to log into the site with the session ID that's now active and he's using our proxy, we might see it. So it's more of a visibility issue. So all we could do is look for, are there any indications of sites that might be vulnerable? So the only thing we could look to search for right here is how many URLs are accepting session IDs on the URL line. So there were a lot, actually. Content spoofing. I believe this is new in the threat classification version 2. So we did actually find an attack that I thought fit in this category, web defacement. We didn't identify the defacement. Who knows if they didn't use our proxy or did it beforehand. But we did identify when somebody accessed the site that was defaced. And I did think it was kind of, this is a lot more interesting than the other one, the put method. So it's a little bit of JavaScript. When you go to the page would download, it would do the typical alert pop-up box and say owned by whatever, 090. But then it would do the window location, JavaScript go off-site, and pull in the defaced page that was on the hacker site and show it in the context of the local site. So from the person accessing the site, it was content spoofing. Oh, that site's been defaced. So showing you, now that I had the information, I went my browser, just showed some stuff. Yes, you get this. Then it does the document window, pulls up the defaced page. And if that's not enough, they added some extra stuff in there. Included in this page was extra JavaScript. So I had to cut some of it out because it was way too long. They encoded it 5 times to try and, you know, get this. So you see 4 more iframes where they're trying to pull up different pages. So I said, okay, now I got to access this page. What does it do? This page, what does it do? So you start going down this rabbit hole. So to cut to the chase, what happened? 2 of those pages, they're trying to install some sort of malware backdoor, something. It's an exe file. I tried to access it, it's now gone. But it's this exe file right here. So in this case, it's trying to actually create a you didn't patch it, you could be in trouble. Another one of the pages tried to install the same program, but now it's trying to exploit something with ActiveX. So now really what you're getting into is, okay, browser security. I think that was mentioned this morning too in some of the keynotes, that man, you're out on the internet now, you gotta be careful which sites you're going to, what's happening. Just some general tips, different things I've heard people doing. I think in talking with Jeremiah before some of his presentations, like, I have a VMware image that's like a throwaway. I go on it for a little bit, do something, you can just blow it away, it's gone. That way nothing will be persistent. Another thing that I use sometimes with testing, Sandboxy, if you want to play with that. It'll sandbox in Java, in this case a browser. Anything that's downloaded, cookies, registry edits, anything, it saves it, and then you can choose to blow everything away, delete it, keep it. So I do that when I'm testing. So now that I know, malicious JavaScript, yes, let's look deeper into that. That's actually a great way how some of this research also feeds back into mod security. But in this case, I knew some of the characteristics, right, looking at the JavaScript, so now I can just search the raw logs. It's a great resource to do some research. And I found, remember the proxy checking site that a lot of people were using to check our proxy? Not only is it gonna tell you, oh yeah, it's an open proxy, which is what's happening here, gives you the response, but then also, I looked at the content link, I said, wait a minute, that's they give you all this extra stuff, more malware. So same thing, decode everything, what's happening. The end result was, I was using Burp Proxy and Sandboxy to see what the heck this did. It redirects you to a different site, then you end up getting some more malware. Now I don't know if you can see that in the back. Once again, that file was gone too. So lots of this malware, it's only on there for a short period of time. Some cool research with the honeypot stuff in the future, if we can do some real time when you see something, go grab it, that'd be cool. My guess would be it's a .wmv extension. There's a nice vulnerability. That would be my guess of what they were trying to exploit. Cross-site scripting, a lot of alerts, all from spammers. I was looking to see, we hear about that all the time, anything, cookie.domain or cooks, anything. Anything so that we can identify somebody trying to steal somebody's credentials. Everything we call, we'll keep watching. SQL injection, one small example here. Just adding on anytime you have a field, add a tick mark, throw some SQL at it, and see what the app does. This one actually just came out last week. We had some discussions on the WASC mail list, and I think I sent it out. If everybody's on the mail list, if you saw it. We have a general rule, high detection, not specific, of course, to individual, like virtual patches, just look for this exploit. We're taking a higher level approach. We have a certain rule on our sensors that says look for anything that has a null byte, because that can be used for a variety of reasons. So that's why this one got flagged right here, a null byte. So I look at the alert, I'm looking at it, and I said, okay, what's going on here? Why did they put that in there? Was it a mistake? One of those anomalous things? Then once I did some research, I said, okay, somebody trying to exploit a specific vulnerability that was released, whatever, early October. Image application will accept certain extensions. PDF is acceptable. But when you put the null byte, right, when it gets parsed internally, you could grab a different file with a different extension and it'll serve it. So trying to bypass some of the controls there. Now, we did see this particular person probe for some different locations. Nothing was successful, of course, because we blocked it. But then we had to have some debate about, okay, would this have worked if we didn't block it? Now, this customer email TXT file is with CART, if anybody has ever used it or looked into it. It's supposed to be located in that same directory, so it wasn't like they were doing directory traversal and going somewhere else. We're guessing this was probably an initial probe. If it worked and they got that file, then we might have seen phase 2 and they might have tried to go get something else. But it's good. We want to see more of this. You don't want more attacks, but we want to see, as far as our data sets go, more information like this where we can categorize it, tag it, present. You can configure configure whatever you want, actually. We could send them certain HTML. We're just giving them status code of 200. So it actually tells them that it worked. But in this case, if it was, depending on the script or person at the keyboard, they're not getting this file, so they would know something goofy's going on.
50,000-volt shock.
That's in phase 3.
Okay.
Considering it's botnet based, it's probably highly successful. It's a lot of stuff's botnet based as opposed to hands-on.
Information leakage. Show you just one quick example. We see a lot of these from database servers, app servers, just all sorts of stuff giving clients stack dump kinds of stuff that they really should not be seeing. So one example here, I put it in HTML just visually so it would be a little more attractive to look at. But stack trace things, it's debugging information that clients don't need. Especially when attackers are doing SQL types of things, there could be stack trace and telling them specifically, oh, well, here's the column or table name of the problem. You're helping them. Down at the bottom of the page, it gave the exact version info. That might be useful. And the other thing I found kind of funny, right-click and say View Source. They even tell you in here, this error page might contain sensitive information. You might consider changing this config setting to off. So either the person didn't know about this setting, didn't care, so it's funny. It's there, it's telling you not to do it. Yes, sir?
I see a lot in my environment is CAPTCHA applications that they're putting out, and they do all the customization for functionality, but then they forget to remove the default error messages.
Yeah, all sorts of problems there. Oops. Last section, sorry, insufficient anti-automation. If you're going to take away a couple trends, if anything, from this, automation is such a huge problem that we're seeing. Almost all these attacks are automated. So thinking back to your normal production environments, how can you help protect yourself? Figure out ways to differentiate a regular user from somebody who's automated, and then figure out how would you want to respond to them differently. Blocking, redirecting, whatever you want to do. Many organizations we talk with, both through the honeypot stuff and then commercially, if you're giving people account registrations, that's a huge problem because they're just, I'm going to go register 500,000 accounts. So you need to be able to mitigate that so legitimate users can get accounts. So here's one example that I would put in this category I kind of laughed at. Poor man's CAPTCHA. Basic authentication, access control against his blog page, so it does the pop-up box, and normally you see the realm, and he just put in there, username equals no spam, password I am not spam. Kind of funny. Now, I have no idea how effective this is. Can lots of these bots that are actively targeting CAPTCHAs, which are probably pretty sophisticated, can it like screen scrape that thing and figure that out and do it? I don't know. I just thought that was funny. He's trying anti-automation. So just to give you an idea. So lessons learned, automation, as I mentioned. But if you couple the idea of automation plus proxy chaining, and the bad guys are so brazen because it's like, what are the chances you're going to be able to track them down? Pretty slim. If you loop through enough different countries and different systems, it's very tough to track down. Application defects, that's kind of the term that Breach uses, but anything where you have server misconfigurations or applications that are using poor programming practices, we're seeing alerts in that category, and it's a big problem. So that's another thing you should go back and look at. And false positives are a pain in the project because it's not in a production environment, so false positives are much higher than you would normally see. So as good as some of the rules are, we're getting some good intelligence. We have a lot to learn. It is very early on, specifically in this project, so we need a lot of help to classify data, look for attacks, get some intelligence. Also, comment, how can we improve? Cards, I think they're going to be helping out. So correlation of events and things like that. So if you want to go and help out, it's the WebInspect.org, projects, honeypots. There's an FAQ, give you maybe some more information, but then you can contact me if you want to help, and I'm sure we will accept any help you can give. And now I can open it up. Questions? I think I'm right on time. Ooh. Yes, sir.
How many proxy probes do you get out of it, like GUIP or something like that? Because I'm doing something similar, and I see a lot of probes coming from Beijing, actually.
Right.
And,
well, the rule set that we have in there right now, the only thing close to that we're doing, it's not the region you're coming from, but it's the RBL check. You could actually mod 2.5, which is a mid-dev release. It's actually on the, I believe it's on the honeypots right now. It has a GUIP lookup feature, if you wanted to try and do that based on a region or locality or something, we're not using that yet.
Just for the pros, just looking if you are an open proxy or not.
Oh, when they're doing a check to see and all, yeah. I mean, we don't have that in place right now, but those are some rules that we could certainly look at.
Are you actually publishing this on like openproxy.org, or is it you just relying on people to be probing for your proxy on 80 or whatever?
It's actually a good question. When people are registering with me saying I want to do a sensor, there's certain information I provide to them. Some things would be, if you're a little bit nervous about deploying this because of the idea, okay, maybe some attacks would get through, you can just shut all that off into the local sensor. Now, if you want to be able to proxy and do all that, you can certainly configure it that way. And then I had other people asking, should I announce this? Or should I just put it on a network? It's up to the person who's deploying it. And we've had a mix. Some people say, I don't want to announce. Unfortunately, our biggest contributor with the amount of data, he did go out to the proxy checking site just to check his own proxy. And now we're on the list and we're seeing tons of stuff. So.
Are you making metrics based on the amount of release you're doing on those? Like, obviously, you can see at the very gross level, if you're publishing,
right,
you're getting out there.
Yeah, a lot of this stuff, as I said, it's falling into data analysis for metrics that we're just not far enough along to get that notebook out. I'm going to take some notes for good questions and thoughts, but whether it's on the
got them on video.
Yeah. The WASC mail list, of course, we're all on it, and we also have our own group mail list if you want to join on that and send questions and stuff like that. So. Yeah.
The scanners you said you were mentioning, were they homemade scanners, open source scanners, commercial scanners? What type of scanners were they?
Generally, because we do have some rules, core rules set and things like that, that will look at user agent strings, and if it's obvious, if somebody ran NICTO and didn't change anything, we could spot it. Most of the stuff seemed to be a lot of homegrown, because it's trying to mimic even certain browsers. Like, we have the rules that if those headers are missing.
When you say scans, are you going after particular phones, or are they doing like the whole gamut of well-known issues?
I was actually surprised that we nobody. Just nobody hit us yet, nobody cared. They have their own targeted thing they were looking for, but previous versions, I did see a few people run an actual scanner, but it was easy because they didn't change anything in the user agent string, but then you could grab their IP and see everything they did, but we're not seeing much of that. It might change tomorrow, who knows?
Have you gripped for like the scanner signatures? Like AppScan and WebInspect will send a ping beforehand. Did you see any of that in there?
Nothing right now. See, this is what's great though. Actually, Jeremiah and I, we've done this every now and then. It's a great resource to go back to, where the real-time analysis is tough to do, but just like you said here, I can take a note, go back, do a search, and I'll tell you, I didn't see anything myself, but that's because I had to do batch analysis and I maybe wasn't specifically looking for that. But it's a great resource to go back to. And that's actually when I went back, like once I identified, ooh, malware, JavaScript, then I went back and found that proxy guy doing that. So.
If that's successful, they actually keep on scanning other guys. So you block that, that's why they're not scanning over you.
Could be, yep. Yes, sir.
I noticed when you were demonstrating the capability of the management console seemed to be pretty robust. Is there any capability for the folks that have deployed sensors to see their own data?
Yeah. Excellent point. Anybody who's participating, whether they're doing a sensor or they want to help out with analysis, they can come in and look at that and search because we need help with data analysis. I believe somebody asked when Jeremiah was talking earlier a general question about we have the data in our console and we use that for doing all this stuff, but there can certainly be some value down the road to figure out how would we release information. Maybe not everything we have, maybe it's too big, but maybe you start posting like, oh, here's November 14th, or here's a few hours. And if we have it in it's just a text format, and if anybody has run Splunk against it or this or that, whatever. So we're gonna have to think about it because there could be some issues with releasing the data outside of what we had to the public, but we see some value, so that'll be something we'll be looking at.
The Incident Storm Center usually does it on trends with specific string texts and specific things they're seeing.
And that's something too that, from my bio slide, I work with SANS, and so I know lots of the guys with D-Shield and all that stuff that there's certain things where, if somebody's doing something cool, you steal a few things and you implement your own. So we learned a lot from the HoneyNet project and from DShield and SANS, some of those metrics where you could say, if you could have some scripts that could obscure some sensitive information, which that can be tricky, especially, it's easier to do at the network level, right? Than to jump in here in an app and make sure you've gotten all the sensitive info out.
Talk to Dave Holzer.
Yeah, exactly. But you're right, there could be some things, so if we want to release some data, if we can anonymize it enough so we're all comfortable, but still have data that would be useful to do metrics. But we're going to look at that, but that's certainly something that I think would help, because we need help with data analysis, so you have to make the data available for people to get to.
I assume you're not proxying SSL through these?
We are, but we're not doing connect method SSL, because then we can't see it. But if they say, oh, I want to connect to you, normally it's a connect to us, and then from us it's SSL. They're going to an HTTPS site, but we still get access to the data. That's what proxy.
Right.
Anybody else? Okay.
I noticed you said you're doing mitigation of brute force attacks against login password after the first year.
Right.
Detected attempts you start talking. Are you doing anything to do that same kind of mitigation against click fraud?
Not yet, only because we didn't have an automated way to identify that.
Right.
Not yet, in the initial phases of rules. But if you go, how can we even identify this? And I'm so much in my production mindset with real companies, that's like, you have to worry about performance, or what if we accidentally block somebody legitimate? In this say, I don't care if I block, nobody should be using this really anyway. So the rule sets you put out there can be very experimental. Batch analysis was how we identified click fraud, searching for lots of those keywords. So we could certainly go back and do a rule set to try it. But yeah, that's the thing. Or if you identify after the fact that maybe something got through, that was actually an issue that we had to deal with recently, saying, hey, we saw this big distributed scanning against this site, reverse brute force scanning. Due diligence, should we alert them? So we did. Didn't hear anything back, but I'm sure they probably knew about it anyways. But those are some of those legal, ethical, talking about WASC, what should we do obligation-wise?
Yeah, we got to start the next one. So.
Okay,
Yeah,
thank
thanks,
you,
Ryan.
everybody. I also have business cards and different things up here. If you have any questions, let me know.